Uh, Hi, today we'll be discussing about Spring Data JPA framework. We all know that Spring Boot is a very good framework. Spring is also very good framework. Advanced is the Spring Boot framework, right? For dealing with the data mapping with the entities, we use the Spring Data JPA framework. It is a powerful framework that simplifies the data access in Spring Boot applications by providing abstraction layer over Java Persistence API. We all know we need to get the data from database, right? How do we get the data from database into the middle layer application? We will build application programming interfaces, APIs, right? How APIs get the data using a Spring Boot framework? It internally uses a Spring Data JPA dependency where it will fetch the data and it will map the data to entity POJO, right? It will map the data to Java object. That is why we are calling it as a JPA, Java Persistent API, because it is going to provide the abstraction layer over Java Persistent API. um, you can also get the data using direct SQL queries. So you can use a JDBC, right? A JDBC template, and you can actually write a native SQL query, and you can fetch the data. After that, after fetching the data, you get the data into result set object, and then you iterate that, you map that data to some POJO. Instead of doing all this boilerplate code, what we are doing here, you can simply directly map the uh, a table data to particular entity. This can be achieved through the Java Persistent API. So that is why we actually, you can see Spring Data JPA relies on several core components. Let me discuss those several core components. What are those components here? Those components, you can see standard Java API for managing relational data. JPA specification, basically it is a standard abstraction, right? Uh, so it is a standard Java API for managing relational data. What is relational data? The data which is stored in the database, which follows the atomic properties, acid properties, right? And also the data is structured and stored in a relational database. So what is the implementation for JPA? Because I told you JPA is just a specification, it's not an implementation. We need a implementation, right, for the JPA, for implementing the the specification, the approach what we decided. So for that we use the Hibernate. We have a Hibernate, right? A Hibernate is one of the good framework, good implementation for JPA specification. Okay, Spring Data JPA builds on top of the JPA and Hibernate, providing simplified data access. So what the these program, I mean the people who actually designed the framework, they simplified the both JPA and Hibernate using a Spring Data JPA. It actually, they built some annotations. They built some simplified approach of mapping data to the entities by using a JPA and Hibernate combination, right? They simplified it. So that's why they're calling it as a Spring Data JPA. They actually removed a lot of configuration. They removed boilerplate code. They simply provided annotations, direct straightforward annotation. That way you can directly map a table name. If you simply specify the table name there, it's going to map the table name, table data to your columns. That can be achieved here. And you have in the repository, you can specify the methods and by which you can actually get the data also. You see, repositories are the interfaces that provide standard data operations. You can save, you can actually, data operations. What are the data operations? You need to get the data, or you may need to save the data, you may need to delete the data, you may need to update the data. For that, these repositories act as interfaces that provide a standard data operations. I'll explain the code also, how this can be achieved. You can see here query methods is also one of the option here. Sometimes you may need to write the custom queries, right? You may have to write some complex custom queries. For that, you need a custom methods defined in the repositories that Spring Data JP automatically implements based on naming conventions, right? I'll also explain the code, how many ways we can retrieve it, right? The data and the things. Let me explain the simple example how we can implement. So how to use the Spring Data JP and Spring Boot project. The first thing is you need to add the dependency, Spring Data JPA dependency. It is required. You need to add the dependency in the pom.xml. If you are using Maven build tool, you need to add that. You can also add it in Gradle or Ant, whatever the build tool it is. You need to add the Spring Boot starter JPA dependency there. And also you have to configure the database. Set up a database connection details in your application properties files. You see here, you need to set up the configuration. Where do you set up this configuration? Application properties file. Define a JPA entity. Okay, this is an important thing. First thing is you need to define the JPA entity. You need to create a class. Okay, you need to mark it as a with annotation at the rate entity. So we are using annotations, right? See here JPA and Hibernate providing the annotations where it simplifies the access of the data. At the rate id is, for making it as a unique id, for primary key kind of stuff we use the at the rate id. At the rate generated value strategy equals to generation type auto. It is, sequentially it will generate a number automatically. As soon as you are inserting a record, it will generate that. So you can make anything as a primary id, primary key, like that you can do that. Create a repository interface. As I told you, you need to create a repository interface. So what is the operation you are expecting from this data? You need to get the details by other name. That is why you are creating a here interface book repository extends JPA repository. The parameters you need to pass the book type. What is that entity type? It is a book type. And what is the id here? The main thing is the long. So you need to specify the two parameters here. First parameter is the entity parameter, for which table or which entity you are trying to retrieve it. And next thing is long. You are going to send a id, id type. What is the id type? Id type is an integer long. You can see we marked in the entity class. What is the id type? It is a long. It is acting as a primary key, id, primary key id, right? Unique id. So you just specify the method declaration here. You are not implementing. You see, you just specifying the method declaration, custom query method, right? And what is the parameter that you are passing for this method? You are passing other. Other. You are passing other name, string details, and the return type is list of book details. That's it. It is over. If you can simply, when you invoke this method by default, automatically it will fetch all the details from the book table. Okay, matching with the other name. So that way it simplifies. It is simplifying the data access. You see here. Okay, inject the repository into your service controller. Perform the data operation. Simple, right? You can do that way. Okay, let me go here. If we can see complete example as well. uh, Spring Data JPA. Wait, I'll explain you. We'll discuss the Spring Data JPA. Okay, well, let's jump into the gigs for gigs and see how we can do it. Okay, here we have added some dependencies, and in application properties file you can see we added data source details and everything. You can see the project structure. Here we have a employee service, employee repository is interface, employee.java is an entity. Okay, employee controller and employee application is the main Java. So now you see here we are going to create entity. We are marking that with a great entity, annotation and generated value. We have a setter getters, right? And then repository. You see repository, we have created the employee type. You're passing employee entity as well as a long type of the id. It is a long. And what we are trying to retrieve, we are trying to find all employees. We are trying to retrieve all the employees. Simple. It is a simple straightforward SQL query. Select start from employee table like that. The operation is created like that. And now you can see employee service. You are going to create a employee service. First I created an interface and then the implementation for the service. You can see here they created that, and then they injected the repository. You can see they auto void the employee repository, space employee repository object. They created that. And you can see um, they actually created a method public array list of employee find all employee return employee repository dot find all. Okay, they are invoking the interface method, repository method find all. That's it. It will return all the data, right? It will return all the data. You don't need to uh, you are avoiding boilerplate code. A lot of boilerplate code is avoided. You can see earlier the jdbc template, once we get the data, first we get the data into result set and then we will iterate it and then we'll map the data, but we're not doing everything here. Simply file repository dot, and it will render the data directly to employee object. No, that will the data will be mapped to the entity directly. You can use that entity later. You can see here find all employee by id, another method I have created. So we have created, you see optional of employee space object. Optional is generally a kind of java 8 one of the functional uh, it is a predefined functional kind of interfaces. What you can see here, in case if no data is there, it will avoids the null pointer exception. So they use this one. And other thing is public wide add employee. You can see here new array list of employees. Okay, you can iterate it. So what they are forming is some employee object, and then they are trying to save that object into db. You can see they actually call the employee repository dot save of passing that employees. That's it. It will save the data directly. So how beautifully it is reducing boilerplate code. You can simply do with the simple repository interface operations. We have created an entity and then we are calling these interface operations to talk to the db, right? And the delete all data is also there. You can see here delete all data. So it is okay. Geeks for geeks code is a little bit confusing, but anyhow, I'm just explaining the thing. So many colors here, but the thing is, you see here slash add. Okay, fine. I don't want to get into here. I hope you understood with you. We can see here the Spring Data JPA is a very good. Always refer the Spring framework website. It is always good to go through the API using the standard official website rather than going different visiting different websites. You can see this getting started here. You click on the getting started. Let us go through this the docs and all. You see they have given a person example, right? And id generated value, at the rate generate value id five primary unique key they are creating, primary key getter setters. And repository person repository extends repository person object and long. You can see the person. The two methods they created, one is save method, other thing is find by id. And in the spring boot applications they used command line runner. If you want to print data on the console, generally we can use a command line runner here. What they are doing, they are injecting the person repository object here, passing the, and then you see they created a person object. First they set a name and they saved that person object there. It is simple example. Okay, getting started scenario. They have given a simple example here. So this way you can actually use the Spring Data JPA It is a very good framework which actually reduces the pain points of accessing the data, getting the data. There are so many query methods are there, like a pagination support, dynamic query execution, ability to integrate custom data access code. Let us go through that there. You can see how we can create a custom queries, how we can actually implement complex queries. So many examples here. Let us explain, the query creation is generally how the query is getting created. The query creation mechanism for JPA works as described query methods. The following example shows what JPA query method translates into. So here you see what is going to happen here. First, when we are creating this method internally, it is going to frame a JPQL. We create a JPQL query using JPQL translating into the following query. How it is going to translate? Select alias u from user table u where u dot email address equal to. So what is that we are passing here? Passing the first parameter email address, second parameter last name. So email address equal to question mark 1 first parameter, and u dot last name equal to question mark 2. So Spring Data JPA does a property check and traverse the nested properties as described, property extension. So you can see underlining thing here, the magic is it is actually translating that into a query, this method, right? You can see here it is translating that. Okay, so how many ways you can, what are the keywords supported in the method names here? You can see we can also use find distinct by last name and first name. So if you use like that, it will translate, it will return the distinct things. If you use and, so if you, it will return end. If you use, it will apply end operations. Okay, if you use R, it will apply R matching, just like a where condition in inside SQL query. If you how do you apply a AND operator? Select a star from employee table where employee name equal to this and employee uh, age equal to something. So it has to match both the conditions. So that is how we use the end operators, right? End operator, or operator, is equals to operator, between, less than equal. So many, you can go through all these things here. It is a very good framework, right? So that is why query lookup strategy. So that is how internally JPA query, it will form that. You're getting it right. You can use this that way, and using JPA named queries. Okay, okay. For before that, I want to explain other thing. You can see here annotation based configuration. So you are going to mark a particular entity, right? In the framework. When you are creating a entity, there also you can directly specify the SQL queries. Annotation based configuration, annotation based named query configuration. This way also you can get the data. You can directly get the data. You can see here. You can directly mention that there here. This also works. Or if you want to use JPA named queries, this is also another way. You know how we can use a named query here? There is XML named query config. Inside XML, you create an XML. So inside that, you are going to create your query here, named queries like this, right? And after that, you can directly use, declaring uh, your directly interface. You can see here. You can declare your interface. And what did you specify? Where is this method named query? Find by last name. So you are going to declare this method here, find by last name. So that way also you can use the named queries. Okay, and there is a special annotation you can, most of the times developers use this, declare. You see, using named queries to declare queries for entities valid approach, works fine for small number of queries, but bigger queries generally, at the rate query annotation, you can directly, if you want to implement custom query, right? You want to get some custom logic. using a select query. Then you can go with the direct query annotation, because you have a customization and flexibility of creating your own query and marking that query to particular method. So what we are doing here, we are getting a user data where email address equal to this one, or if you want to apply some like parameter, you can apply it. Okay. uh, See, at the rate query allows the definition of advanced like expression inside the query definition. See, it is allowing that, right? So that way you can use the query annotation. Using a query annotation, you can actually, what you are doing here, you are actually writing down your own query. You may need to include some join keyword. You may need to include where class or some other foreign key constraints. You want to frame a query, then you can go ahead with the using this at the rate query. It is giving a flexibility of writing your custom query. You can see here. Okay, the named query. So generally using a named queries to declare queries for int is valid approach and works fine for all small number of queries. As the queries themselves are tied to Java method that runs them, you can actually bind them directly using Spring Data JPA at the rate query annotation rather than annotating them with domain class. This frees the domain class from persistent specific information, co-locates the query to the repository interface. So basically using earlier I have shown you, you can directly write the query at the JPA level, but instead of writing there, because sometimes it is a uh, kind of confusing approach, right? You can directly use at the rate query annotation. You can mention all the queries here on top of the actual methods. Okay. And there is another annotation I want to tell you, native queries. So generally you see here, here it is a JPQL, Java Persistent Query Language. It is not a straightforward native SQL query. You see, wherever you have used at the rate query annotation, inside that select you from user u, where u dot first name like this one. This is not a direct native query. Okay, it is a kind of JPQL. We are kind of JPQL. We are using it there. But if you want to use a native query, there is a at the rate native query annotation. You can see you can directly use like this, direct table. We are using the select query directly on the table name, actual table name. But here we are using a entity names, right? And inside the select query we are using entity names and entity column names. But here we are directly using the table, actual database table, and we are applying the query details there. We are fetching it. So you see here, public interface, user interface extends, JPA repository, user comma long. You can see here, you can actually mark any method using at the rate native query. And sometimes you want to implement a very complex query, and you are very good with SQL language, structured query language, so that you don't want to mess up with the this JPA and entities and for framing a JPQL. If you feel that's kind of confusing approach for you, you can directly use a native query, and you can actually deal the SQL complex SQL query using a native SQL language. So that way, see, the native query annotation is mostly composed annotation for at the rate query native. So at the rate query of native query equal to true, but it also provides additional attributes such as SQL result set mapping. So these are internally you can use. You can actually customize the native queries as per your requirement. You can see here. There is another example. You see native query. We are using the two queries. I'm using the two queries. First thing is select star from users where last name equal to that, and select count of star from users where last name equal to that. Okay. So you can see a similar approach also works with the named native queries by adding dot count suffix copy of query. Okay. Now you can see here native query returning raw column name value pairs. See, they are returning the raw columns directly. Okay. That way you can get that. So here how you render the data, how you map the return the result. Here you are mapping it map of string comma object. Okay, single map result returned by tuple. Multiple map object. Second thing you can see. uh, so you can see here multiple map results backed by tuples. So basically you can see you can use the native queries. If you want to directly compose a SQL structured query language on top of the uh, tables that are actually created inside the database, native database, right? That way you can get that, right? So this way you can actually get the data, okay, using a native query. um, I hope you understood what are the different ways you can actually apply. There are so much keywords, so much usage. You can actually customize the queries, and you can deal with the native queries. You can apply so many. You can go with this Spring Data JPA. There is a vast majority of the keywords. Approaches are there. You can actually override a specific method, and you can do lot of stuff. There is a customization also. It is allowing lot of customization. Now if you want to use a sorting approach, you can see here JPA repository, and as the second parameter we are passing a sort, JPA sort. The following example uses sort JPA sort, including unsafe option for JPA sort. We are passing the sort object. You can see here. So how you can sort it? It find by and sort. You are going to sort by first name, last name. You can see because we passed the second parameter as a sort object here in your interface. While you are creating repository interface, you need to pass the second parameter as a sort object also. Okay. You get that right now. So sometimes whenever the data is very large, I want to tell you, let's say your table is having millions of data, 10 millions, 20 millions of data. How do you get the data at a time? You cannot get all the data at a time, right? You need to get the data page by page, and you want to display the data on a page. Let's say 10 records, 20 records per page. So then you need to get the data 20 rows at a time, not all the data. So for that you can actually scrolling the large query result sets. So there is a paging option, paging features, offset based scrolling, key set based scrolling. Those options are available. Let's see the paging option, how it can be done. Let me explain this thing to you. So here you can see here paging and sorting. uh, so this is just for sorting, and here a person class, uh, there is a paging and sorting direct example. Let me show you. In the repository you can directly specify the paging option. See pageable. You can see here pageable. We are passing pageable object. Okay, you can actually specify the paging, iterating large results, and sorting, limiting. You can all see here. Okay, how it can be done. Okay, query results. Where it is it? You see paging object. We are passing the paging at that way. You will get a page of data. You can specify the pageable object inside pageable. How many records you want to fetch it. All these things, and you can actually achieve like that. You're getting this point, right? That way you can actually use both pageable object and sort object. You can see both things I can also use, and also limit option is there. So many keywords are available. The Spring Data JPA, you provided so many keywords. You can go through the each and every keyword. I'm not explaining all the each and everything. I'm just giving a road path, path to the road, simple road path for understanding this JPA. What is JPA, and how you can use the Spring Data JPA? What are the different various features of the Spring JPA? You can all see this here. Okay, this is a very good. Spring Data JPA is a very good framework, data access framework. Okay, simplifies all these things. Okay, I hope you understood what is this Spring Data JPA, how we can use it, and how it would be so useful, right? You can achieve, the data access, accessing the data and mapping it to Spring entities very easily. It is a very good framework. If you want to use it with the Spring Boot or Spring framework, you can use it, right? So many uses are there. It is avoiding lot of boilerplate code. Other thing is it is providing you the customization of creating your own SQL queries. You can also use native SQL queries, named queries. Using iterate query annotation, you can frame a jpql queries. You can also create a native queries also if you want to do that. Okay, and it also provides us a paging option. Page wise, how many records you can get. You can also it also provides a sorting options. So many, options are available with the Spring Data. So that way you can actually use the Spring Data JPA, and always try to use the Spring Data JPA, a very good framework, and you can use it. Okay, and thank you for listening to this video.